Hi guys, today we'll be doing the AMC10 2004A Problem 25. The question is, three mutually tangent spheres of radius 1 rest on a horizontal plane. A sphere of radius 2 rests on them. What is the distance from the plane to the top of the largest sphere? So first of all, we need to draw a sphere. So the sphere would be like this. It's going to be difficult to draw this though. I understand that these don't look really like spheres, but at least it's going to be very difficult to draw. So first of all, we need to connect up the points, the centers, more specifically. So as you can see, this makes up the this shows that this connects up the centers to make this equilateral triangle. So, and remember, because we know that the radius of these are 1, the side lengths of these are 2. Because we know that this is 2 now, we now have to look at the larger sphere. The larger sphere because the larger sphere will have to rest on these, it will create a bit of confusion because, well, the confusion is that mostly because there is a small space in between, and as this rests on it, the space will cause this sphere to go lower. So it's going to affect. So it's not just going to be 5. It's going to have to be larger. It's going to be smaller. So because first of all, let's say this is just, let's make a side view of these, and then there's a larger sphere resting on top. So, and we know we have the triangle down here. So first, we're gonna have to do this. We know the radius is 2, and then this is up to here is going to, and then the depth and we know that the depth of this up to this is going to be 1. So let's start. So we have to do 2 plus 1 plus, because we don't know what this is, we can write it as x. So for a closer look down here, the x, we're gonna have to do this, because we have this triangle here. We can make a type of prism like this. Okay. Okay, you know what? Let's just use this. So basically, we're going to have to draw something like this, which is basically just a prism. So we need to know, because we know that this is going to be a side length of 3 because of the larger sphere. We have to find, and we have this center point here. We make a triangle. a triangle like this. We know that this is 3. We just have to simply find this from the equilateral triangle. So from the equilateral triangle, we have this, and we can form a 30, 60, 90 triangle. You might ask how? Well, first of all, we know that these are 2, and that we know the height is, square root 3 from here. So this is 1, and then we have this 30, 60, 90 triangle. From this point here, we can form another 30, 60, 90 triangle. This 30, 60, 90 triangle will be smaller, because from this 30, 60, 90 triangle, it will be way smaller. Because of how smaller it is, we're going to have to do this. You can connect it to this point here. So as this is clearly another 30, 60, 90 triangle, we can do the form of 1 to square root 3 to 2. So we know that so let's say this is now x. Ignore the, not x, shoot. Let's say this is a. Because now we know that's a, we can now and that this is 2a over here, we can now use a Pythagorean theorem. So for a square equals 1 plus a square. So this will be 3a squared equals 1, and a equals square root 1/3. Or in more simplified terms, square root 3 over 3. So now we know this now, which is square root 3 over 3. We now have to find this using the Pythagorean theorem. So we have 9. Wait, actually, shoot, I said this wrong. Sorry. All right, a is, yes, sure. We only found this part. We didn't find, what we're trying to find is 2a. So it's actually 2 square root 3 over 3. So now we can do it. So 3 squared is 9 minus 12 over 9. So this would be equivalent to 69 over 9. And then we have to square root this, which in terms we will get square root 69 over 3. However, this is not the answer yet, because we found x. So now 3, so we have to add 3 now, which is over here. So the answer is B, 3 plus square root 69 over 3.